Hello, everyone. Welcome to Gradient Descent, episode 2. Yes, we made it to the second episode, Alex. It's great. How do you feel?
Oh, you know, it's just fun to get a chance to talk about these things. Um,
Yes. Cool. Yeah, and for those of you who are joining in for the first time, it's Gradient Descent. We talk about AI stuff. We try to go deeper than most podcasts out there about one specific topic every episode. My name is Vishnu Vettrivel. I'm the founder and CTO of Wisecube, and I have here with me Alex Thomas, who is the principal data scientist at Wisecube. With that out of the way, let's get straight into our topic of the day. Today, we're going to be talking about LLMs as judges. And just a little bit background into this before we jump into it itself. Alex, I want to start out by sort of talking about the dirty secret in machine learning and AI that we all know, and maybe not a lot of people outside of the AI industry sort of know this, which is the real secret behind AI is sort of humans,
mhm.
right? Humans in the loop. This has always been a struggle as far as I've been involved in this industry. Is like, hey, we need label data, we need ground truth, we need annotations, right? And
Yeah,
whether it be like the models that you and I were working on, like, trying to build in for medical coding or readmission prediction, or, even in like companies like where, where we have speech recognition models, it was always like, oh, we need more label data, more ground truth, more slagers, more cowbell, more cowbell. um, and and I just want to give the scale of this problem, right? Like, so it the people don't realize how big of a problem and how big of an industry this is,
yeah,
where humans are involved in teaching the machine learning models or the AI models, right? And it's
yeah,
just like a lot of people, well, you don't know, there's this whole industry of software companies that are dedicated to just building tools, managing human workforce so that they can work to train these AI models and then teach them in a way, right? And so,
yeah.
companies like obviously the first ones that come to mind, like Mechanical Turk, Amazon launched a while back, based on this whole idea of this artificial and like this whole chess playing machine, so-called machine that
Yeah.
you should look it up. There's a whole history of this where there's this guy going around beating other chess masters of the day, and turns out
I
there
think
was
it was like the
actually
17th century or something like that, right?
and there was actually he was hiding in the little box pretending to be a robot, right? And anyway, AWS named this service after that device, so-called device. But what AWS service does is allows you to sort of farm out a bunch of tasks to a whole bunch of people who can then come in and sort of annotate and judge these tasks, so that it gives you sort of a grounding, or what is called the ground truth, so that the machine can actually learn from that and use that as the way to sort of learn what's right and what's wrong,
Mhm.
depending on the context, right? So um, and it's so big, this industry has gotten that it's $1 billion industry. There's companies like Scale AI, which a lot of people probably haven't heard of, multi-billion-dollar business, and the founder is like a billionaire that you've probably never heard of. And so I just wanted to set the context in terms of what is the scale of the problem that we're dealing with when we're talking about training models, and what is the sort of underlying you know uh, catch that's always been there, and how we think LLMs potentially can help change this economic reality, right? And
Yeah.
so,
So
yeah, go ahead.
yeah, like you said, like we in AI, we for most problems that we are trying to solve, we're trying to replicate human performance, and that means we need to capture what human performance is in order to have the models, have our algorithms build a model of that performance. Um, so this especially becomes an issue with LLMs as these very powerful tools are allowing us to do new things. So it's often the case that there's not a data set out there for you to train on, or possibly even like it's too complex to build a data set to train on. Let's look at an example of things like judging automatic summarization. In the past, they've used they've used metrics like rouge and blue, which are sort of comparing the text to each other, see how similar they are on a character level. But as everyone knows, like that's not really a good way to decide whether a summarization is good or not. Because like, what if I summarize it correctly, but just used words in a different order? Could you be the same words, but I just like reorganize the sentences? So if you have something that's producing summaries, the only real way to judge it before LLMs was have a person look at it. Like that was your choice. So
Right.
this issue of like we have all these businesses that are out there for judging, but if someone's looking to use these new LLMs to build it, that can be a major slowdown. But
yeah,
this is, on the other hand, like it seems, I think, to a lot of people outside of AI, it seems something. It seems odd, or perhaps even untrustworthy, to use the LLM as a judge. So it's like it's a hard thing for people to understand, and there really are some serious caveats to using an LLM as a judge. Like if you do it in a overly naive way, you can end up having your judgment be extremely biased towards outputs.
Yeah.
So
And just to set the context here, I want to point out that what we're talking about is usually when the process involved when you're training a new model for a new task or domain, right? And so you're like, okay, I want to do, I don't know, language translation comes, right? Let's say,
yeah,
or I want to do like, in our case, we were trying to do like medical code prediction or readmission prediction or something like that. That's when you need this sort of ground truth to begin with. Now, there are certain classes of problems where you don't need a lot of annotated data and a lot of ground truth or labeled data, and you can do a lot with what's known as unstructured, like, unlabeled data, right? And so, um, and as a lot of listeners know, there are two stages of training in LLM as well. The whole training on all the data in the internet, and that's mostly unlabeled data that they work with, but there is a supervised training phase of it, right? Either be
yeah.
RLHF
Well,
or
the thing is, we're
what have
training a
you.
language model, like you said, training a whole internet. That is something that's an example of some of a supervised model actually that doesn't need human labeling, right? Because you get these sequence of you get these texts, right? You're just trying to predict the next or the next word or a word in a context window or something like that. So it's inherently like labeled by like the actual data itself, right? So when you're trying to predict,
right.
a
So you
language
don't
model,
need the human there,
exactly.
and that sort of at least yeah. But the other problem we're also talking now in the LLM world, which is now that we're starting to use LLMs in all of these different domains and applications, the question becomes, okay, how do I know how good the LLM is doing on my data, right? And
Yeah,
then how do I judge that, right? And so there's the training aspect of it, and then there is, hey, I'm just starting to use my LLM, and I want to know how good it is. I want to evaluate how good it is,
mhm,
right? And so there's
yeah,
that aspect as well, right? So
yeah,
because most
and that's where
people
we,
right now
yeah,
are not really training foundational models. They might be fine tuning it,
yes.
but right. So yeah, good.
But they needed, like you said, that they need to decide which model is best for their data or for their
Mm-hmm.
task.
Mm-hmm.
And that's where we start the things where these tasks are being asked for. Like there's not a simple, there's not really a simple and labeling task. It would, so let's take the example of something that assists with coding, right? Coding assistant. So um, a lot of people are using that now, and that's not something you could easily go and be like, oh, I'm going to go create a Mechanical Turk job, and I'm going to put out, my 1,000 generated code files and have people judge them. You can't have, because in human labeling, you consider tasks differently depending on whether they require generic knowledge, like, oh, is this does this sentence make sense or something? A fluency test. That's just general knowledge. Versus, is this code well written? which requires specialty knowledge. And so you can't really, it's much more difficult and much more expensive to gather specialty knowledge, like is this code well written, than it is for like other tasks like simple labeling. So
yeah,
that's where.
By the way, on that note, the at least the predominant way people, like you said, evaluate different models is by just looking at benchmarks, right? And this whole topic of benchmarks. And for those of you who don't know, just benchmarks are sort of standard data sets that have been labeled, right, typically by humans. So these for different tasks, right? Whether it be like, as Alex pointed out, hey, if you're trying to use your model for coding, there is a coding benchmark. In fact, I just saw an article about this popular coding benchmark, SWE benchmark, that claims that, hey, that benchmark may not be as good as everyone thinks, and there's a lot of problems with the way people interpret the results, and maybe the models don't do as well on it as we previously thought. But that is sort of the predominant way where people evaluate LLMs, is like looking at these standardized benchmarks, which are human annotated, human labeled data sets for different tasks. And then they say, okay, how well does this LLM do on this benchmark, which represents the kind of task I wanted to do in my domain or application, right? And maybe maybe talk a little bit about that, Alex. Is like, what is the risk? I mean, so why shouldn't people just rely on the benchmarks? I think we've already hinted at it a little bit, but what is the risk of just looking at the benchmark results and just doing nothing else, I guess?
Well, I'd say the concerns are sort of, there's two. Well, there's one which is sort of a more general one, and then there's an LLM specific one. The more general one is, you mentioned like, oh, these are like human annotated, and that's often the case, but it's not always the case. Sometimes people they develop a heuristic to create these data sets. So, for example, having having a Q&A data set. Where you're trying to find the appropriate document for a given question. So one thing I've seen that is part of the PubMed QA process is they'll take the titles of articles, and they have a pipeline that can turn the articles into question statements, and then they say, okay, we did that, and we're going to say that this article is the answer to that question. So there's not really a human in labeling that answer there. So there's sort of like a intuition that makes sense for them doing that, but there's no real human in that loop. But the more specific one for LLMs is that we talked before. LLMs are trained on the internet, and for these open benchmarks, they're on the internet. So it's a pretty common situation for these LLMs to have already been exposed to that data. So what that means
is the risk of memorization is what you're pointing out, right? So yeah.
And there is a paper. Let's see, which one was it? There's a paper where they talk about this issue of leakage, and so it's this.
We'll add it to the show notes at the end, but yeah.
And they go through a test on different tasks, and they find that, especially on coding, for example, as well as and then on general writing, that like they're able to find evidence of leakage of basically where it's already seen the data enough to where there's a bias in the results.
That's definitely a problem. And then, like you already talked about, like there's also the problem where like simple tasks versus complex tasks. The benchmarks are not always there to measure. There's a lot of benchmarks for the simpler tasks, but less so for complex tasks. And of course, the benchmarks are always not foolproof. There's a lot of subjectivity in how people evaluate some of these results, and so on. Now, so this is the problem with just relying on some of these benchmarks. So, but with the LLM as a judge, what we're saying is like, hey, what if? I mean, it's hard. It's first of all expensive and hard to create these benchmarks that are human annotated, or like any ground truth or golden data set, let's say, right? Which is what the benchmarks are, and we, there's LLMs. We want to evaluate how good LLMs are, but LLMs as judge is sort of like saying, why don't we use the LLMs themselves to judge them, how good they are? Maybe a different one, which is scary in the sense that it's like asking the fox to guard the hen house a little bit, right? And so what are the strengths and weaknesses you think of using the LLM as a judge?
So the strength obviously is like similar with a lot of other tasks that were sort of out of reach of machine learning and AI previously. Is that you could do a lot of complex tasks using the LLM now. So it gives this really great benefit of like, oh, I can actually build my data set and label it, even if it requires expert knowledge. I can do it relatively cheaply with an LLM. There are other issues like how do you validate the LLM's decisions? Like, for example, if you were using the LLM to judge your output, how do you measure its quality as a judge, right? And like the way it's commonly done now is you take these benchmarks where there are where it has like answers, like a variety of answers that are good or bad, and you see if the judge LLM can actually determine which ones are good, which ones are bad. But again, they come back to the issue of benchmarks. And so if it's already seen that data, then like it's not really a held out data set, right? Like it knows which one is good or bad somewhere in the model. Now, has it memorized it enough to where it's completely reliable? No, definitely not. So I think like right now that there's this balancing act that you need to do where LLM as a judge is almost inescapable at this point, because if you have to pull in a human, it's gonna take a long time. It's gonna be more expensive. So a lot of people, they don't really have that option. They need some way of being able to measure it. So then really what you have to do is you can use a benchmark to figure out like, okay, I think my judge is doing well. Then you need to start gathering live data. That's at least my recommendation. Is you start gathering live data. And
let's get into that. Maybe we're talking. Yeah, let's talk about how. So someone is considering this. Okay, they've already decided to use LLM, which is pretty much everybody right now. And they obviously, let's say they don't have the time to go like build a valid golden data set for their task or domain, and they just want to get started, but they're looking at this LLM as a judge thing. They heard about it, and how do they avoid the traps? How do they make their this whole judging pipeline and process using LLMs more reliable? What are some of the things you think they should be considering?
Well, one, I think a lot of sort of like the initial concerns about LLM as a judge are a bigger problem if you have a simplistic approach to LLM as a judge. So let's say you're using an LLM, and you generate an answer, and then you turn around and ask. So it's a question answer thing. So you turn around and then ask the same LLM, for this question, is this a good answer? That's going to do very poorly. And it will be overconfident, and it'll say, oh, it will be more likely to say it's good, even if it's not, because you are giving it the same data, and so it is likely to identify it as good data. You're giving it its own output. What you really want to do is you want to try and create some layers in between those two. So, for example, one of the things that we do with Pythia is rather than like just giving the generated text, you break the generated text into claims, and then you ask it to judge whether these claims are supported in the reference text.
Yeah, you mentioned Pythia, so I just want to let people know Pythia is our reliability AI observability solution where we help you detect how good your LLM-based solution is, detect hallucinations, and a whole bunch of other things. But you're talking about, okay, breaking down your complex task into sort of smaller tasks that can be then easier to evaluate and easier to judge, right? And the chances of hallucination and chances of like, the LLM getting it wrong also goes down. And we actually did a whole paper on this that I'm sure we'll link in the show notes, but we were able to prove that, hey, complex tasks actually, LLMs, the same LLM will do worse than trying to break that complex down into smaller chunks and then stringing a pipeline of that, or right, a chain, if you will. But yeah, so that's one strategy, right? Which is like take the complex task and break it down. what are some of the other strategies to avoid like, problems with the LLM as a judge approach, you think?
So
Because one of the things that I've also seen is like, hey, they use multiple different LLMs. Yeah, so
you can use a different LLM, but in the leakage paper they bring up sort of this issue of like the sort of problem coming into now is so many of the really big LLMs have seen the same data. Like they're different, maybe different model architectures. Maybe they're the training parameters are different, so they're not the same model, right? But they've seen very similar data. So you can reduce the risk of this sort of self bias by using a different model. You could also do some fine tuning where you train it on like sets of you create basically a data set about judging, and then you train it specifically to do that. The issue with that is that probably that's not going to be very generalizable. So if like you train it to judge, let's say, so you can do question answer and something like that, then it'll only be good for like data similar to what you've fine tuned its judgment training.
Right, and then obviously there's other techniques that are that people are starting to use, which are like, hey, use different the size of models, right? Like, hey, if you're using your main LLM for your application is, let's say, GPT-4 or 4 or whatever, try to use an older version of the model or a smaller sized model, right? Like maybe 3.5 or something smaller, right? Or like use lower precision grading scales for easier interpretation, and like some of these techniques that is talked about in the paper as well, to sort of avoid this sort of memorization bias or leakage bias that you're talking about, right? So
I think it serves like as one final thing is that although we can't like involve necessarily humans in the overall judgment, I would say having a small set where you can gather human judgment on a smaller set and then comparing the LLM as a judge to see how it rates the human performance on judging. That's also a good one if you can afford it.
So just so I understand, what you're talking about is, hey, let the LLM, so build out your LLM as a judge pipeline, use different LLMs if you can, like, or pick whatever LLM, and then now you have a mechanism to judge the output of your main application. So let's say you're building a RAG application that uses GPT-4 or whatever, then you take the outputs of that application, you feed it to this LLM as a judge pipeline, and maybe you have different LLMs that are not maybe used in your main pipeline to sort of judge how well your main application is doing. And then you take those results that now a different LLM has judged. So LLM A is the one that's in your application, and let's say LLM J is the one that's in your judging pipeline. Then you take the output of the LLM J pipeline, and then you're suggesting like, hey, maybe even a subset of that, have that be validated by a human.
Right? That's one technique. Another technique would actually have your labeler judge the output of LLM A and basically give it the same task as LLM J, and you compare their agreement.
So that's more like a golden data set. Now you're trying to build your own golden data set to sort of compare to sort of measure how well the LLM J is doing. This is the same problem that we had with Pythia. Is like, if you had a system that sort of is built to evaluate the outputs of an LLM, how do you evaluate that system? It's like the who's watching the watcher problem.
Right.
So,
and I say, like, as far as like one other sort of final technique, this is probably going to be the one that's like maybe a little bit more expensive, but it can give you some really good insights into your problem. Is I get to use your sort of LLM A and LLM J. Is take a data set, run it through LLM A, and then give those outputs to two judges and your judgment pipeline, your LLM J, and then compare the inter-rater agreement.
Okay. For those of you who don't know, don't know what we're talking about, inter-rater agreement should be obvious, but it is the percentage of time in which, like, a judgment pipeline like this, where you have different raters or judges, agree on the same judgment for the same data points, or what percentage of data points they agree on is the same labeling, right? Is that
Yeah,
Alex? What is the
yeah,
official? Yeah.
yeah. That's a perfect explanation of it. And what that tells you is that you might have a problem that has low inter-rater agreement, right? So this has come
Mm-hmm.
up in the past when I was doing something for clinical decision support. So the idea is that
Mm-hmm.
you were getting like a patient case, and you were supposed to find PubMed articles that are relevant to it. And when it was given to judges to establish what the inter-rater agreement was, it turns out it had really low inter-rater agreement. And if that's the case, then that means that there's a lot of subjectivity in your task inherently.
Mm-hmm.
So, and that's sort of where I get to maybe like sort of a last one, which is what I mentioned earlier, is gathering data from your service. So if you have some sort of signal of user satisfaction on the output of your system, maybe that's like you can give them some sort of like you see on ChatGPT, like the up and down votes you can give to the responses, or other things that can signal whether you agree with it. You can gather that information, and that's probably the closest to real thing you can get for understanding how good your system's doing. And then you want to make sure that your judge can actually figure that out.
Yeah, and this may be sort of the meta learning or meta guidance is like, hey, for the problem at hand, whatever task you're trying to use the LLM for, first figure out what kind of problem it is. Is it something that has a high inter-rater agreement or not, right? And based on that, your strategy of how you want to use the LLM-as-a-Judge might actually vary, right?
Yeah.
Because as you pointed out, if it's a very subjective thing, where even the humans cannot agree on what the right answer is, then there's a probably high chance that the LLM is also not going to get it right. And even if it gets right, like which human, what is the right answer? And it's sort of open to interpretation, right? And so that is always hard one, right? So
in which case, in that situation, really what you want to focus on is not getting it wrong. In some of these ones with low inter-rater agreement, there's lots of correct. There's a few correct, but there's lots of ways to get it completely wrong. And so you just want to try and make sure you're not getting something like completely nonsensical. You want to look for reasonable. And I think this goes towards like something that I don't want to go too much deep in the weeds here, but then you start getting into like, oh, how do you actually phrase either the guidelines for the human or your prompt? Do you want it to figure out like, oh, is this the right document for this answer, or is it a reasonable document for this answer?
Right.
Because really, what you're looking for
that makes sense. Yeah, and so I know we want to wrap up here, and I wanted to sort of touch on what are some of the things that people could go look at, and we'll obviously add a lot of show notes with the papers and things we reference, but also maybe talk about some of the platforms and frameworks that support this whole mechanism of LLM as a judge. I know you've looked into a few. Maybe we'll just leave with that, so people have some next steps they can start following up and how they want to use this. Right? So
AWS Bedrock has the ability to use like LLM as a judge built into like their pipeline. So you can like pick a model and then judge it on your given data set. A lot of the frameworks out there also that you use for like programming for your LLM applications like LangChain and Llama Index, they have tools and components built in for doing this as well. Another one I want to call specifically is actually DeepEval, where they've actually done a lot more things that they've built into their library for doing LLM as a judge.
I see.
Where is that?
Yeah. So we'll put links to all of those tools we talked about in the show notes. But I just want to end with like one final note, which is like, I mean, clearly, at least this seems to be a very promising direction in terms of at least getting a handle on this whole problem. Like, how do we know how well my LLM is doing in my application? And how do we go about improving how well it's doing over time, right? And really just building this sort of evaluation pipeline / feedback loop
Mhm.
into your AI systems is very important. As we all know, like building machine learning applications over the years and decades, we've learned this is like, hey, whatever you think your model's doing, you can always try to improve it, and that sort of continuous improvements and built-in feedback loop is what you have to think about as well, and not just training your models and putting it out there. So yeah, any other thoughts, Alex, before we close this episode?
Yeah, I would say like some things. Like I would say is that something I've seen is pretty common out there is for people to release their LLM application with just some like spot checking. And I understand that that's tempting to do. It's tempting to like see this difficulty in measuring your application and sort of like throw your hands up and be like, oh, well, we just stated it. No, it's worth putting in a little bit of time, even if you have to do it just LLM-as-a-Judge and you have like no other resources for it. It's definitely worth putting in that little extra time, at least trying to get a measurement. And there's going to be a lot of I think progress on this in the future, because like as we sort of are reaching peak data, right? Being able to get the new data that's like labeled is something that people are going to turn to LLMs to do. So this is going to continue to improve. Yes, one of the papers we link has this whole like taxonomy of the different techniques for doing LLM as a judge. So like already there's it's not just a simple where you just like take the answer and like give it right back to the LLM and ask it. Like you said, there's picking multiple LLMs. There's decomposing the output and then asking the LLM about that. There's all sorts of techniques that can get over these hurdles. So I'd say that just put in the effort to measure your stuff.
Yeah, I think that's very good advice. On that note, we're going to end this episode of Gradient Descent and hope to see you in the next one. Thanks, everyone.
Thank you.